Right, so you wanted to take a deep dive into attention is all you need. And believe me, this paper, it's a big one. It's completely changed how we think about AI, and especially how computers can, well, understand language, really understand it.
Yeah, it's a game changer for sure.
So before we even get into the details, just imagine trying to teach a computer to not just read words, but to actually get them, grasp the nuances and the context, all the stuff we do without even thinking. It's hard.
It's really complicated. And for a long time, we relied on these models, RNNs, LSTMs.
Yeah.
They were like the go-to. They worked kind of like an assembly line, processing language one word at a time.
So if you read a book, just one word, then the next, trying to get the whole story that way, sounds slow.
Exactly. And that's where the problem started. These older models, they really struggled with longer sentences.
Like remembering a grocery list, by the time you get to milk, you've forgotten what was at the beginning.
Perfect analogy.
Mm-hmm.
This whole sequential thing, it created this bottleneck, right? Limited how much info the model could handle. Plus, they relied on these things, recurrence and convolution, kind of complicated math stuff.
Okay, and just for a sec, even though I know our listeners are pretty savvy, could we get the super quick explanation of those just so everyone's on the same page?
Sure. Recurrence, basically it means the model kind of loops back on itself, uses info from the words before to figure out the current one.
Right.
Like you're guessing the next word in a sentence based on what came before it.
Okay, makes sense.
Convolution, on the other hand, is more like looking at chunks of words all at once, trying to find those patterns, the meaning in those little groups.
So it's like these models are trying to put together a puzzle, but piece by piece. What did the authors of Attention is All You Need find wrong with that approach? What did they see that others missed?
Well, they realized that those older models with that step-by-step thing, they were missing the forest for the trees, so focused on individual words that they weren't really grasping the whole meaning of the sentence.
So we're stuck in the weeds with these old models. They can't see the whole picture.
Yeah.
How'd the authors of this paper propose we climb out and see the whole forest then?
They scrapped the whole thing, threw it out. It's a whole new architecture called the transformer.
Here's where things get interesting. This isn't some little tweak, right? It's like they redesigned the car instead of just giving it a new paint job.
Yeah, it was a total game changer. And the key is this idea of attention.
Okay, now that sounds more like a self-help book, not computer science. What's attention in this context?
It's actually pretty intuitive. Think about how we read, right? We don't just process each word on its own. Our eyes are darting around, focusing on certain words, making connections to understand the whole thing.
So it's like reading a mystery novel. Your brain's trying to put together the clues, right? You're paying attention to what matters most.
Exactly. And that's what the transformer lets AI do. It can focus on the important parts of the input, even if they're far apart, and figure out how they all relate.
Okay, but how does a machine decide what's important? It's code, not a brain, right?
Right. So that's where this scaled dot product attention comes in.
Uh-oh. That sounds complicated.
The name's a mouthful, but it's basically how the model gives each word a relevance score, like how much it matters compared to the others.
So higher score means the words are more related, more important for getting the meaning.
Yep, exactly. It's like highlighting the key parts of a sentence, understanding how they all fit together.
And this is a big deal because
it solves that whole long sentence problem.
Yeah.
We're not stuck going word by word anymore. The transformer sees the whole picture all at once and figures out which parts matter most.
So back to our book analogy, it's not just reading line by line. It's like the model can flip through the pages, make notes in the margins, actually understand the whole story, just like us.
And that ability, right, to make those connections over long distances in the text, that's really where the transformer shines.
No wonder people were freaking out when this paper came out. It's like giving AI the ability to read between the lines. But wait, it gets even cooler. Didn't they actually visualize this attention happening?
Yes. You can see these attention maps that show you exactly what the model's focusing on as it reads.
So you can peek inside the mind of the machine, see it thinking. That's incredible. Okay, so new architecture, this attention thing, it all sounds amazing in theory, but this wasn't just some thought experiment, right? They actually showed that this works, concretely. The transformer beat out those old models.
Oh, absolutely. And the paper, it's got the receipts. Like table 1, it lays it all out, the nitty-gritty, how much more efficient the transformer is, faster, less power hungry.
So it's less clunky. We can get the same results, but more elegantly.
Totally. But it's more than just being powerful, right? The cool thing is how flexible it is. The paper looks at all these little tweaks, tiny changes to the model.
You're talking about table 3, right?
Yeah, exactly. And even small adjustments to how the attention works, boom, huge improvements across the board. Different languages, different tasks, shows you just how much potential there is in this approach.
Okay, but I know what our listeners are thinking because it's what I was thinking when I first read this. So what? It's better language processing, cool, but what's the big picture? Like, why should I care if I'm not building the next AI?
That's the million-dollar question, right?
Right.
It's easy to think, oh, better translation's fine. But it goes way beyond that.
This isn't just fancier Google Translate then.
Not even close. One of the coolest things is how well the transformer can do all sorts of things, not just translations. The paper even tested on this thing, constituency parsing. Basically, figuring out the grammar of a sentence, and it crushed it.
Really? So they find this one solution, this attention, and it's like a skeleton key. It unlocks all these different doors.
Yeah, and we're seeing it everywhere now, not just language stuff. Image recognition, audio processing. There's even people looking at it to understand how our brains work, the human ones.
Hold on, are you saying AI is giving us clues about ourselves now? That's kind of wild.
Right.
Okay.
Like if this attention thing is so fundamental to how the transformer learns, maybe it's a piece of how we learn too.
Whoa, that's getting deep. We've gone from computers translating to, like, the nature of consciousness. This deep dive took a turn.
It did. And if anyone wants to really see this happening, the attention, it's wild. Go check out figures 3 through 5 in the paper. They show you what the model's focusing on as it reads, like heat maps of its brain. It's kind of beautiful, actually.
I'm going to have to check that out. Well, listeners, I think we've given you a lot to think about today. This paper, it's not just about AI, it's about how we understand the world, how we think, maybe even who we are.
And that's the power of a really groundbreaking idea, right? It makes you question everything.
Absolutely. Until next time, keep those deep dive requests coming. And remember, sometimes the most complicated problems, they lead to the most elegant solutions. And those solutions, well, they can change the world.